Hey, what's up YouTube? This is Iconic, here with Organic Chemistry Made Simple. And in this video, we're going to talk about chirality. So before we jump into the chemistry, let's just go over the idea of chiral or chirality. Let's say if we have my left hand, right? It's a terrible drawing, but let's just say I draw left hand, and then this is a mirror, and let me draw the mirror image, right? So right hand, obviously. Something like that, right? So obviously this is the mirror image. This is the mirror image of that. Now, when we talk about when something is chiral, it is non-superimposable on its mirror image. Now, those are some big words, but let me just write it down. Non-superimposable on its mirror image. Right, so basically that's a fancy way of saying that for my left hand, right, if I were to take my, this imagine this part right here, this is a thumb, right, this is the thumb part, and these are my fingers. Doesn't matter how I orient my hands, right, there is no way where I can take this image and put it directly on top and it'll match up, right? There's no like possible way where I can take it and then they'll match up. So it's like you have your left hand, right? And then you take the mirror image of it, right? So it'll be like that basically, right? And if you place it like the whole superimposable, the whole idea of that is like you can't place its mirror image on top of it. Like it'll never be possible to exactly match it up. So that's what it means for something to be non-superimposable on its mirror image. So it doesn't matter how you orient this part right here, it'll never match up with its original image. That's what the whole idea of superimposable means. So basically, you can't take its mirror image and you can't place it on top and it'll be equal. So that's what it means, superimposable. Now, of course, in chemistry, that can be applied to almost anything, to everyday objects and whatnot. But chemistry, we're talking about molecules. So if a molecule is chiral, that means you can't superimpose, you can't take its mirror image and place it on top and it'll be exactly the same. It won't be. So if a molecule is chiral, that means if you place its mirror image on top of it, it won't be the same. So, and also for a molecule to be chiral, there's another fact that we have to know, that there has to be no plane of symmetry. No plane of symmetry. So now before I go into examples of chiral molecules, one thing I want to mention is a chiral center. So there's two terms. There's chiral molecules, right? And then there's this whole idea of chiral centers. Chiral centers, or they have many different names: chiral carbon, stereogenic center, stereocenters, or whatever you want to call it. I just like using chiral centers. But yeah, these are all synonymous terms. So in order for something to be a chiral carbon or a chiral center, there has to be 4 different substituents, however you spell that. In other words, 4 different groups, right? Not necessarily 4 different atoms, right? Don't get that mistake, but 4 different groups. And I'll show you what I mean by not 4 different atoms. And along with that, it has to be well, if it has 4 different things, then we know it's going to be sp3 hybridized. sp3 hybridized. And if you remember, anything if there's sp3 hybridized, it has four things attached to it. So let me give you an example and it'll make perfect sense. So let's say we have our central carbon, right? And then let's give a hydrogen right here, fluorine, bromine, and then let's add a, what do you call it? A methyl group, CH3. Right? Now, before I jump into the whole chirality, if this molecule is chiral or not, let's go to this. Let's say if this molecule does have a chiral center, right? So we look at the carbon. Does it have 4 different substituents, 4 different groups? And the answer is yes, right? It has fluorine, bromine, hydrogen, carbon, right? It has four different groups. It's sp3 hybridized, has four different things attached. So we would say that this is a stereogenic center or a chiral center. Either way, same thing. Now, this whole overall molecule, well, is it chiral or not? Let's see if we can draw the mirror image, right? Then we will get something like this. I don't have much space, but the Br will be on this side, fluorine will be here, hydrogen stays where it is, and then the wedge will be on the other side, the methyl CH3, so CH3, right? So this is the mirror image of this molecule basically. And if you were to take this, right, and place it directly on top of that, you'll see it's not going to be the same exact thing, right? You'll take this, right, and you place it directly on top of that, we would say it's non-superimposable. It means you can't, if you place it on top, it doesn't match up. That's basically that's what it's saying. So this, we would say that this whole compound, this whole molecule, right, is chiral. It's a chiral compound, or it's chiral. And this carbon, we would say that's a chiral center. So that's basically the whole idea of chirality. Before I go end the video, I'm gonna leave you guys with a few examples of chiral molecules and whatnot. So let's say we have something like this. Terrible cyclohexane drawing. Say OH. And then another OH. Another OH. So that's one. Oh, can you guys see that? Okay, cool. So we have that. And then let me give this one. These are a little bit more complicated, but I think I should be able to do it, no problem. NH2 and cool. Now let's see if these two molecules, right? Identify if they're chiral or not, and if identify any stereogenic centers or any chiral centers. Okay, so for the first one, so take a minute if you guys want to pause the video, see if you can figure out for yourself. But I'm just gonna go into it. So for the first one, does it have any chiral centers? Just by looking at it, you can see it doesn't. But first and foremost, it's not a what do you call it? It's not a chiral molecule, because why? It has a plane of symmetry, right? If you basically draw a line down the middle, right, you can see the left side is equal to the right and so on. So because it has that plane of symmetry, we would call this molecule achiral, right? In other words, not chiral. And the reason why, basically, I don't know, if you guys are looking at this, and you'll probably think, okay, this is probably a chiral center, but the reason why it's not, because it doesn't have four different substituents. So I'm gonna zoom in on this point right here, right? So it's a carbon, has a OH group, right? And then there's a hydrogen somewhere in the back, right? And then on this side, it's bonded to a CH2, and on the other side, it's also bonded to a CH2. Right, so I just basically, I zoomed in on this point right here. Right, this point right here. So if you look at this molecule, you would, it kind of looks like it is a chiral center, but in reality, it does not have four different substituents, because CH2, CH2, they're the same, so we say that is not a chiral center. Let's go to the next one. Right off the bat, if you look at it, you can identify some chiral centers. For example, this is a chiral center, right? Over here and over here. All three of these are chiral centers, and this is a chiral molecule. And also another thing is, don't get confused right over here. This is not a chiral center, because why? You have two hydrogens. So in order for something to be a chiral center, we said it has to have four different substituents or four different groups. And then remember I told you there was a rule where it can be four different atoms, right? So let's say, for example, going back to that first example, I had a fluorine, a hydrogen, right? And then I had was it a Br or something? No, yeah. And then I had a, 1 second. I had a CH3, right? And then I added a bromine or something right over here, right? Let's say, what if I added a propyl group, right? Or no, let me add, say, something like this or whatever. A bunch of carbons. There's a carbon, 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 or something like that. Even though, this is a carbon, this is also a carbon, but you can see this has like a bunch of different carbons attached to it, right? So we don't look at the atoms, but rather we look at the whole group itself. This is CH3 and this is C whatever, you know? They're different groups. Therefore, this is a chiral center or a chiral carbon or a stereogenic center. Um, Anyways, that's the whole idea. This is just an introduction to chirality. In the next video, I'll go over RNS configuration, or the Kahn, Ingold, pre-law, whatever it's called, something like that. But yeah, hopefully you guys let me know if this video helped. If you have any questions, please leave it in the comment section below, and I'll see you guys next time.